Hello, and today's purpose of the day is I can use the distributive property and factor by grouping. Let's take a look at the warm-up. Number 1, factor 63x to the third y to the second completely. Take a moment and go ahead and factor that monomial. So don't forget, you need to make a factor tree to help you factor 63. So 63 breaks down into what two numbers? You got it, 21 and 3. And then 21 breaks down into 7 and 3. So here I would have 3 times 3 times 7 times x, y, and y. Now number 2 says find the GCF of 35a squared bc and 50ab squared. So we need to completely factor both monomials and see what the two have in common. So we could make a factor tree and break these two terms down, or we could just think about what are the factors of 35 and 50. And I know that 35 breaks down into 5 and 7, and 50 would break down into 25 and 2, and then have 25 break down into 2 5s. So really, the only thing that jumps out that the two have in common would be the number 5, or the factor 5, and then I see they both have an A, and they both have a B. So 5AB, and that would be the GCF of those two monomials. Now let's answer the question of what is a factor? Please jot down a few notes on your paper right now. Do you have some notes written down? Good job. Let's go over this together. So a factor is, an integer number or variable that you can multiply by something to get a product. So I'll write down an integer. And the reason I write down an integer is because factors are typically, you don't see them as decimals or fractions, right? So an integer or variable that you multiply by something, so by another term, to get a product. Feel free again to jot down any of your notes that you had written down for what is a factor. So for this section, 8.2, we are going to be using the distributive property. So recall that when you have, for example, 5x times the quantity 4x plus 7, you get 20x squared plus 35x. So again, we distribute that 5x to both terms inside of the parentheses. Now we will start with the end result of 20x squared plus 35x and factor it to become the original form of 5x times the quantity 4x plus 7. So let's look at the first example, using the distributive property to factor. So the process that we will follow is we will find the GCF, then we will do what's called undistribute. So work backwards. So here at number 1, we have 15x plus 25x squared. So the GCF of 15x and 25x squared, without having to make a factor tree, if we think about this logically, that would just be 5x. So I'm going to write out 5x. And now I'm going to write parentheses, and I'm going to say, if I'm at 5x, how do I get to 15x? What would I multiply by? Well, 5x times 3 would give me 15x. And then again, if I'm at 5x, how would I get to 25x squared? So multiplying by what? Well, 5x times 5x gives me 25x squared. And so now I could check my work if I wanted and say, okay, 5x times 3 is 15x. 5x times 5x is 25x squared, and make sure I get what I originally started with. And I do, so I know that I'm right. I'm just going to get rid of that so you can see my answer clear. And now let's look at number 2. 12xy plus 24xy squared minus 30x squared y to the fourth. So again, I look at all these three terms and I want to take out the GCF. So what goes into 12xy, 24xy squared, and 30x squared y to the fourth? Well, it might be helpful if you break it down and just look at the numbers first and then the variables second. So what goes into 12, 24, and 30? Well, 6. So I'll take out a 6. And they both have one x, or they all three have one x, and then they all have just at least one y. So now if I'm at 12xy, if I write parentheses, or excuse me, 6xy to get to 12xy would be multiplied by 2. 6xy to get to 24xy squared would be 4y. And 6xy to get to negative 30x squared y to the fourth would be a negative 5x, and then y to the third. And then again, don't forget you can check your answer by going back through and distributing that first term to all three terms inside the parentheses. Now we're going to use a method to factor that's called factor by grouping. So please jot down these notes. We will use if there are 4 or more terms, terms have common factors that can be grouped together, there are 2 common factors that are identical or additive inverses of each other. And an example of an additive inverse is if we have x minus 5 and 5 minus x, those are additive inverses because they just differ by a factor of -1. So if I were to multiply one of those two binomials by a -1, that would turn into the other binomial. So again, right here you can see that if I take out, if I multiply -1, so if I have 5 minus x and x minus 5, if I multiply x minus 5 by -1, -1 times x is -x, and -1 times 5 is +5, which is the same thing here, it's just written in a different order. So then I could flip-flop these and write 5 minus x. And so the two binomials are essentially the same thing, but just differ by a factor of -1. So again, called an additive inverse. So please make sure you jot down these notes because it's important to know when you need to factor by grouping. Now let's look at an example of factor by grouping. So the process we will use is to 1, regroup by like terms, 2, undistribute like we did in the previous examples, 3, write as factors, and 4, perhaps check for an additive inverse, and 5, check your final answer, perhaps by foiling. So I'll write down FOIL right next to that just to remind us. Okay, so first step here is to rewrite terms, regroup by like terms. So I see a 2xy plus 7x minus 2y minus 7, and I would rather put the 2's by each other and the 7's by each other. So I'm just going to rewrite these as 2xy minus 2y plus 7x minus 7. So I've regrouped by like terms. Now you are going to break down, or we will break down this example even further, and I'll group the first 2 terms together and the last 2 terms together. So out of 2xy minus 2y, those are the only 2 terms I'm going to look at right now, I'm going to take out the GCF. The GCF of 2xy and -2y is 2y. Now if I undistribute, 2y times what gives me 2xy? Well, times by x. And a 2y times what gives me -2y? A -1. Okay, so now that part is done. Now I'm going to look at the second half. Now I'm going to look at the 7x minus 7, and I'm going to pull out the GCF of those 2 terms. And that would be a positive 7, so I'll write down a plus 7. Now if I undistribute, 7 to get to 7x would be multiplied by x, and a 7 be multiplied by what to give me -7? Well, a -1. So I've finished grouping up my 4 terms by 2's, taking out the GCF, and undistributing. So we've done step 1 and step 2. So step 3 now says write as factors. So here I see a 2y in front of a set of parentheses and a 7 in front of the second set of parentheses. Those 2 terms are grouped together, and that will turn into a 2y plus 7. Now it's really nice that I see here an x minus 1 and another x minus 1. You want to see the same factor written twice, or perhaps an additive inverse in those parentheses. That's a good sign. That means you've done this problem correctly. So how I write that factor is I just have to write one of those x minus 1's because I see them twice. That means they're, we see that within the problem, so we're going to pull that out, and that's going to be part of our answer. So my final answer here is really, I'm going to circle this, and then I'm going to check it when I'm done. 2y plus 7 times x minus 1 will get me back to the original problem up here. But let's go ahead and FOIL and make sure that we're right. So let's go bring that up a little bit. If I FOIL 2y times x, I get 2xy. 2y times negative 1 is a negative 2y. 7 times x is plus 7x. And 7 times negative 1 is negative 7. So did we get what we started with in the beginning? You bet we did. We just have a couple things that are in a different order, but that is okay to have terms in a different order. You just have to make sure that they're all there. So they are. So there's a 2xy, a 7x, a negative 2y, and a negative 7. So we have all of our terms. We know we did this problem correctly. So again, I can rewrite my answer so you see that. 2y plus 7 times the quantity x minus 1 would be the factored form of this example. Let's take a look at another example of factor by grouping. So the process is written at the right, the same process that we used in the last example. So let's go ahead and get started. The first step is to regroup by like terms. We see a 15a minus 3ab plus 4b minus 20. I'm going to leave those as they are because they already have some things that are grouped together that we could essentially factor out or find the GCF of. So I'm going to go ahead and leave them. And I'm going to break up the first two terms and then the second two terms together. And now I'm going to go ahead and factor out the GCF of the first two terms. So what's the GCF of 15a and negative 3ab? Well, a 3a. So I'm going to take out a 3a and now I'll undistribute. So 3a to get to 15a would be a 5 times 5, and a 3a to get to negative 3ab would be a multiplied by minus b. And now the GCF of 4b minus 20, I'll factor out a 4 because that's the GCF. And 4 times what gives me 4b? B. And 4 times what gives me negative 20? A negative 5. So now, as I look at my problem, I see that I have 3a times 4, and then I see a 5 minus b and a b minus 5. So if you can recall from a couple slides ago, that is an additive inverse. So what we need to do now to change one of those binomials to be the other so that they're the same, because that's what we need to eventually get to so we can write our factors, I need to factor out a negative 1. So I always like to see the variable written first. So I'm going to keep I'm going to double underline so we can kind of put those together. I like to see the b minus 5 written first as opposed to the 5 minus b, so the variable written first, excuse me. So what I'm going to do is I'm going to take out here a negative 1, and I'm going to move it to the term in front. And this is okay to do because if I change the sign of one term, I have to change the sign of another term to keep this factor equal. So if I take out a negative 1 here with the 5 minus b, this negative 1, and I'll change it to red, will be multiplied now by the 3a. So I'm moving that negative from this factor just to the term in front of it, and that is okay to do. So what that 3a becomes now is it becomes a negative 3a. And when I take a negative out of this 5 minus b, well, this 5 becomes a negative 5, and this b becomes a positive b. So I simply change all the signs of that term, and then I change the sign of the 3a term that's in front of it. So that 3a becomes a negative 3a, and then this becomes b minus 5, which is good because that is now the same as that term. And so I have 3a, negative 3a plus 4 for that first factor, and then a b minus 5 for the second factor. So let's check our answer by foiling to make sure that we have indeed all 4 of our products. So negative 3a times b is negative 3ab. Whoops. Negative 3a times negative 5 is a plus 15a. 4 times b is a plus 4b. And 4 times negative 5 is a minus 20. So as you look up back at the beginning, we do get all 4 products, just in a different order, but that's okay. They can be rearranged, but they need to have the same signs and be of the same value. And that's a good way to always check your answer by factor by grouping, especially when you have additive inverses, because they can, like I said before, be somewhat trickier. So again, if I write my answer, oops, need to get the pen, I have negative 3a plus 4 times the quantity b minus 5, and that would be my answer here in factored form. One more side note is I could have left my one of my factors as 5 minus b and kept, as you look up here, the original 5 minus b, and I could have changed the b minus 5 to a 5 minus b. I just happened to change one into the other of what I wanted. So my answer could have looked a little bit different here, but I still could have, it still would have been correct. And that's okay too. It just depends on which additive inverse you like to change. But you'll always see me change to have the variable written first, and always change like this, the 5 minus b. That type of additive inverse is the one I would typically always change. Thanks for listening. Have a great day. Bye-bye.